All right, so let's take a look at this one here. So we have a snow day going sledding. Find the final speed at the bottom of a hill when you sled 82 meters with a 35-degree slope. Okay, so a 35-degree slope. And we're sledding the distance there is going to be 82 meters. And we're starting at rest up here, right? So starting up here, the velocity is 0 there. Okay, and we want to know how fast we're moving down here. And we're going to use energy. You could do forces and kinematics. Don't get me wrong, you could do that. But we're going to do work in energy because that's what we're practicing here. So are we including the Earth in the system? Why or why not? Yes, we are including it because whenever there's a change in height, we want to include this system because there's a change in height. That's how we decide whether or not. This is like a really easy way to decide. We're going to include the Earth whenever there's a change in height. Okay, we're going to draw a free body diagram. Okay, there's no friction in here, right? So neglecting friction, yeah. So we have gravity. And then we would have the surface touching here. So we have a normal force, perpendicular surface. Nothing else is touching it. So that's the free body diagram. Which ones do work on the system? So remember, our normal force, not going to do work because the displacement is down the ramp, right? The normal force doesn't. It's perpendicular. Okay. And then gravity is internal to the system. So we say none. None, no forces do work. Because the gravity we're including as part of the system. The Earth is part of the system, so gravity's internal force. It does not do work on the system. All right, compute the work done by external forces. Okay, so the work is 0. Solve for the final velocity, then find expressions for final and initial velocity. So the initial velocity, we have to consider whether there's kinetic energy and gravitational potential energy because we've included the Earth in the system. There's no kinetic energy to start because it starts from rest. So this is the initial position. This is the final. So the initial is m times 9.8 times whatever the height is. We want to know what this height here is. And that height is 82, because of the right triangle, 82 sine of 35 degrees. That's an expression for the initial energy there. For the final energy, down here, so for the height, we're picking a reference. We've got to pick a reference height for h equals 0. Okay, so that's the reference height. For the final energy, we don't have any, again, you have to consider whether there's kinetic energy or gravitational potential energy. In this case, there's no gravitational potential energy because we're at height equals 0. So we just have kinetic energy. Okay? And then those are our expressions. That's the work. This is the initial energy. This is the final energy. Okay, now solve for the final velocity. We're going to use work is the final minus the initial. So 0 is going to equal 1/2 mv squared minus whatever all this is. 9.8 times 82 sine 35 is going to be 460.9 m. And so then you can solve for v. V is going to equal, the m's will cancel, by the way. V is going to be 30.4 meters per second. Okay, on the same hill, you ask a friend to push you to give you a moving start. Starting with an initial speed of 1 meters per second, find your final speed at the bottom of the hill. Reflect on which parts A through D will be the same, which parts will be different in this scenario. Okay, starts with the same height, same free body diagram, same bottom spot, same distance, all of that stuff is the same. What's different is so the work is still 0. The initial energy now has some kinetic energy. This part's not 0 anymore. So this is going to be 1/2 m times 1 squared plus m times 9.8 times 82 sine 35 degrees. And that's going to give you 460 let me just double check. 9.8 times 82 sine 35 degrees. And then we're going to add in 0.5. Okay, so that's going to be 461.4 m. The final energy is still the same. That part didn't change. It's just that the initial part, we started with some kinetic energy. So that's going to equal 461.4 m. M's cancel. So because if the work is 0, it's the final minus the initial. If that's 0, then the final and the initial are equal. Then you can solve for v. Times 2, it's going to be very, very, only slightly different. Still 30.4 meters per second. It's about the same, only slightly faster. What was the other one? The other one we ended up getting 30. So like this one was actually 30.36. This one is 30.37. So only slightly faster. Okay.